Welcome back, everybody. Bill's here, and in this episode, we're going to continue our platformer game concepts. And today, we're going to kind of finish laying the groundwork before we can really start talking about advanced movements. And the way we're going to do that is through implementation of a state machine. So, at the end of the last episode, we built this template right here. So, we've got a tile map, we've got our character that can run, he can jump. We've got collisions and everything, and we've got a little parallax background, and we still can't make that jump. So that's what you call bad level design right there. Anyways, so one thing we're going to do real quick before we jump into the state machine is right now we have our constant for acceleration, and then our player moves by this function right here. And we're going to adjust this slightly because right now we can only speed up or slow down by acceleration. But if we want different like speeds, acceleration, and then deceleration, we want to add that functionality in. So I'm going to add a new variable called deceleration. I'm going to make it slightly slower. And then we're going to come down to this function, and we're going to actually pass in some arguments. So we're going to pass in acceleration, and I'm going to call it a float. But then we're also going to say it equals our player acceleration. And then we're going to pass in a deceleration of type float and pass in our deceleration. So what we're doing here is we're saying, hey, this is our argument. We want it to be of type float, but then the setting it to equal our acceleration means if the user does not provide a argument, then just assume that this value equals this value, which is why when we go to our process, we're not getting an error without passing in arguments because we're providing default arguments. Like for instance, if we get rid of this, now we're going to get an error there because it's like, hey, we don't know what this acceleration value is. And then what we're going to do is we're going to adjust this right here in our velocity. So we're going to say if move direction x is not equal to 0. So if our move direction x is not equal to 0, that means that the player is pressing a key, so we should be accelerating. Correct? But then, if the move direction is equal to 0, then we want to use our deceleration value. And then what we're going to do is we're going to come up here and we're going to switch this to 5 just to kind of play around. So we speed up real quick, but see how I let go and see how he takes a while to slow down. So that means we can get up to speed almost immediately, but he slows down. And so that lets us know that, yes, we are accelerating and decelerating at different speeds. Now, with that one adjustment, we can start moving on to our state machine. So what a state machine is it's essentially a way of separating our code into different states without just putting it in one file. So like one way you can do a state machine is, you can do like an enum of states. And, you can call the first one like idle, and then the next one like run, and then the next one, jump, fall. And we can have this enum of states. And then, in our physics process, we could rewrite this to be like match, state in states. And then, we can do like idle and have all of our code for idle and whatnot. And it's going to give us an error because we haven't filled this out and whatnot. And then we can have a custom function, that's like idle state, like that. And that's going to give us an error too. Ignore that. And then, so we can do states like this where we basically have a match statement. We go through each state, and then we have a function that handles that. But then our player file is going to have tons and tons and tons of functions, and it's going to get really long. Which, if you want to do that, by all means, you can do that. It's just I like to separate my code out more than that, and so I like to do a state machine based on nodes over here. And so what we're going to do is we're going to go to add child node, and we're actually just going to call this, we actually just want like a node. And so we're going to get a node right there. And we are going to give that node a name. And so we're going to rename this node right here state machine, out a capital A. And so the way the state machine works is each node is going to be an independent state with a script attached to it. And then our player right here will run this proper script for whatever state we are currently in. And so that allows us to kind of split up our code so it doesn't get too long. It makes it manageable, and then it organizes it, and then it'll allow us to add some advanced features into our platform. So we're going to start adding a bunch of states. We're going to need 1, 2, 3, 4, 5, I think 6. So this first one, I always call locked. We're not going to do anything with that yet, but I always have a locked state, which is like if you're using like a cutscene or pausing the game or something, you can throw the player in the locked state, and I usually just don't have it take input. Idle, when the player is not moving. Run, when the player is moving. Jump refers to the player just going up. And then I have one that I usually call JumpPeak, and then fall. So those 6 states are our player states. We're going to go through and add some code to each of these. And I'll explain kind of why there's 3 for jumping. And we're actually also kind of setting up for the next video where we're going to talk more about jump mechanics. And so we'll leave that discussion for later, but we're just going to kind of set the groundwork for it now. So the next thing we need to do is we're going to make some scripts for this. So in our entity, I'm going to create a new folder, and I'm going to call it player. I'm going to drag these into there, and then within that folder, I'm going to create a new folder called states. So first thing, we're going to create a new script. I'm going to call this player state. We're going to hit create. And then we're going to open up that. And so this state will be kind of like the base class that'll set up kind of like it's going to be the outline for each state. And it's going to have all the functions that each state should have and be kind of the blueprint for each player state. So up top, we're going to put class name, and we're going to call this player state extends node. So adding class name allows us to create a class, which is basically a blueprint of functions and properties and names and other things that we will then use to extend functionality, create other classes, objects, and whatnot. So with this right here, our player state class, we are going to write down a few variables. So we're going to call it var states. I'm going to set this equal to null. And that'll be a property that holds all of the different states within our state machine. Next is going to be player. That will be a reference to our player, and we will need that to access all of the player variables, nodes, and whatnot. And then the last one is going to be name. And that'll be for, actually, we're going to set this to a string. And this will just be for naming the state in case you want to, write some debug information to see what the state is doing. So now we're going to add our functions in. And so the first we're going to have function enter state. And all these are going to pass because they're not going to do anything. So this will be called when the state, first enters. And then we have function exit state. And this we will call when the state is exited. And then we are going to have two more. We're going to have function draw. So if you have like ammo for a shooter or hearts for your health system, these individual kind of sprites can be drawn manually in the draw function instead of adding nodes and all of that. Alrighty, now that we have that, we are going to create another script, and we're actually going to attach it to our state machine. This one we're just going to call states. And this is just going to hold references to all of our nodes so that we can then access them and use them. And the reason we need references to these nodes is that each node is essentially a state. And so, like, we basically have an array of different nodes with scripts attached to them. And we're using the node to hold the script that we need to run for that state. I do not know. No, this is just run. Perfect. So we use the nodes to hold the script that we want to run for that state, and we can then kind of cycle through and assign, one of these state nodes to be the current state, and then we run all of the code for that. And you can name these whatever you want. These are just what I like to call them. Alrighty, we have all those, so let's save that. And now we can move on to actually hard coding the player. And so this is where we're going to have to shuffle around a good amount of code. We're going to have several functions that still stay within the player code. And these will be functions that we will use several times. So like handling, or not handling, but like handle gravity. Gravity applies to a lot of different states. So we'll keep that in the player so we don't have to have like a different handle gravity function for each state per se. Same thing with horizontal movement. Handling horizontal movement, we're going to keep in the player so we don't have to add several different horizontal state functions. And then for organization's sake, I'm going to add a region right here and call it main loop functions. And then we're going to end that right here. And then I'm going to add another region called custom functions. And then we'll come down and end that right here. And that way I can just kind of minimize my code so I'm not super disorganized and whatnot. And we need to add a few more variables for the player for the state machine. So these will be state machine. So we just need two variables here. We need our current state, and we want to store our previous state. And then we're going to add a function right here called change state, where we pass in our next state. And so what we're going to do is we're going to say if the next state is not null, meaning the state does exist. So we're just checking that it does exist. So we are going to set our previous state outside of brackets. So our previous state is going to equal our current state. So basically we're saying, okay, the current state is now the previous state because we're going into a new state. And we're going to set our current state to the new state. And then we're going to call previous state dot exit state, and then current state dot enter state. And then I'm going to throw this line in right here. And this is just a debug line that I have, so you can see exactly what states you're doing and how everything's transitioning. Okay, now we're getting an error right here saying new state is not. That's why. We want that to be new. New state, new state, new state. Okay, perfect. That's all working. Nice. So we can close that down. And then real quick, we need to add in the draw function, just because we added the draw function into our states, so into our player state. So we want to just add that right here. Now we need to go into ready, and we're actually going to put some code in our ready state. And so we're going to initialize our state machine. So we're going to say for state in states.getChildren, and I'm just going to temporarily put pass. Actually, no, we'll cut out this whole thing and then we'll go through and explain it. States.state equals, states.states equals states. State. I don't know why that did that. States. Code completion is awesome, but at the same time, like something like that, like where it's going to force me, I want to go to a new line, not select that. So code completion is cool, but sometimes it really gets in the way. States.player equals self. And then we're going to say previous state equals states.fall. And then current state equals states.fall. That's right, for Godot, you can't put parentheses around it. So now we're going to get an error for states. And that's just because we don't have, this is a node. So this is our state machine node. And we don't have a reference for it up here. So we're going to add first a reference for our camera, just because we have the camera. Nope, that is the wrong symbol. Good job, Bills. And then let's add on a reference to our state machine. And now that should fix all of this right here. And this is state.states. Alrighty, perfect. So now we've initialized all the states. And so what we're doing, we're saying, hey, for state in states, and state can be literally any variable name. We're just saying for this thing in states.getChildren. So we're looking at states, this node, and grabbing all the children. And we're saying for each one, the states variable equals states. And what that does is that allows us, we're passing a reference of this node into each of these individual nodes, which allows us to kind of access each node from within whichever node we're in. Same thing goes for the player. We're saying the state player reference variable is equal to this object, which is our character body 2b, which is our player right here. So if we go into our states, our player state, remember, we have a states variable, which grants us access to the different states so we can transition from one to another. And we have our player, so we can access all of the player variables. And so that's why we set it up like this, and that's why we have to pass in these two variables. And this is called dependency injection, meaning the state is dependent upon a variable, and this right here is us essentially injecting that variable and its variables and data and all of that into this state so that we can access that data. So now we simply just go through, we say current state.draw. So now anything we draw, we'll draw, because the character body is going to run every frame. And so it'll go to ready when it's ready, and then it'll call the draw loop and it'll draw anything we need to draw. And in physics process, under the input states, we're going to say update current state. We're going to call current state dot update, and then we are going to keep this here, and we're eventually going to get rid of this function and these functions because that's going to all be managed independently. So now we're going to go through and make sure we have all the functions that we need. So get input states, we need that one. Horizontal movement, we need that one. The next one we're going to add is going to be handle falling. And what this will do is essentially we're saying see if we walked off a ledge. If so, go to fall state. So if the player is not on the floor, meaning we have fallen off like a ledge or something, we just want to change state. So we change state to states.fall. So now, because there'll be several states where we need to check if we have like walked off a ledge. And so instead of repeating this function in each of those different states, we just put it in the player, and now we can access it by just saying player.handleFalling. And it makes it easier for us. We're also going to have our handle jump. So watch this. We're also going to shorten this right here. And then I always like to enclose my ifs in parentheses all the way, and then we'll take these back. So that just shortened that a little bit. So that one's all good. Okay. And then we're also going to have one where we handle landing. So now we say if the player is on the floor, then we want to change our state to states.idle. Perfect. And then we have handle gravity. And on handle landing, we're actually going to right here also put jumps equals 0. We're going to reset our jumps there instead of resetting it there. And then right here, we're also going to for our handle gravity, which we may or may not use, we might just do this independently in different states, just depending on the need. But just in case, we're going to do the same thing we did up here. We need to pass in delta because gravity is dependent upon delta. But then we're also going to pass in this gravity variable, which will then we're then going to pass in this gravity variable, which will be used to actually add the gravity. In case we want to change gravity for some reason, we're just going to make this another one of these arguments that has a default value. So if we don't add that value, it'll just default to this, which is the gravity we've defined way up here for the player. Alrighty, with those functions now coded in, we can get rid. Actually, we'll leave the handle animation just so we can copy and paste that code, but we're not going to use that. And then a lot of these too. So let's go to our idle state first. So we're going to create a new script to attach to this node, call it idle state, create it, and then we're going to need to make a few little changes. So first off, we need to extend player state. And then we need to take basically these base functions and copy them and paste them in right here. And then an enter state, I always say name equals idle. So I set the name of the state there. Exit state, we're not going to do anything right now. Draw, we're not going to do anything. And what we want to do is we want to update, and then we're also going to put a function down here. And we're going to call it handle animations. And we're just going to pass for now. So in the idle state, we need to call some basic movement functions. We're going to call handle falling. If for some reason, we're not moving, but if we get pushed off a ledge, we need to be able to register that and transition to the proper state. We're going to call handle we're going to call our handle jump. Alrighty, so within our idle state, within our update function, first thing that we're going to do is we're going to call the basic movement functions. So first, we're going to call player.handleFalling, and even though we're in the idle state, if we for some reason get pushed off a ledge, we need the player to be able to register that they're no longer on the ground and transition to the falling state. Also, in our idle state, we need to be able to jump. So we're going to call our player.handleJump. We also need to be able to register movement side to side. That's not the function we want. We want horizontal movement. So even though this won't move the player that's handled in the run state, this will allow us to register the input for moving to then transition to the run state. And then what we're going to do is we're going to say if the player dot move direction x is not equal to 0, then we're going to change states to states dot run. And then finally, we want to handle our animations, and this will be called locally just to handle our animation, and that's this function right here, and it'll be very simple. We're just going to say player dot animator dot play. And we're going to play our idle state, and then player dot handle flip h, just to make sure we're facing the right way. So with that, we have our animation all set, just our idle state flipping the right direction, and then we have all of our necessary movement states. And the reason we don't have handle animations in our player state is because, like, right now we have this, and if we keep it in the player state, it's going to get really long with all the different states and animations, especially when you have a lot of transition states, like a state for transitioning from falling to landing before, like, you're like either idling or running. It's just much easier to handle code like that locally within the state, which is why we make state machines in the first place, to prevent all of this from getting nice and long and ugly. Alrighty. Let's go to the run state next. So we'll click on our run node, add new state, call it run state. Get rid of all of this code. And we're going to extend player state. We'll add in our main functions. Call this our run state. And then we'll have our exit state. And honestly, I don't use the exit state function a whole lot. I've maybe used it like a handful of times in all of like the coding I've done. It's handy to have because we will need it at some point. We'll handle all the movements. So we'll call player dot horizontal movement. We'll call player dot handle jump. So we'll want to jump from running. Player dot handle falling in case we run off a ledge. handle animations, and then handle idle. So those two will be local functions. And then we also need to, oh, we don't have to call the draw function in here. Like in the idle state, we have it, but if we don't use it, we don't necessarily need it. It's like we'll leave it empty there. Okay. So next up, let's call function handle idle. And this will essentially just send us back to the idle state if the player stops moving. So if player.move direction x is equal to 0, meaning there's no input, then we're going to want to change our state back to our idle state. And then, last but not least, let's handle our animations. So this will be player.animator.play run. There we have it. There's our run state. So now let's go on to our jump state. So once again, we'll add a script. Call it jump state. And all these are going into our player folder. We'll move them into that states folder afterwards. And get rid of all of this and call extends player state. And then this is all kind of just the redundant name equals jump. However, this one's also, we're going to use this once more. So we're actually going to set the player's y velocity to equal jump speed once we enter the state. So as soon as we enter the state, we want to set that velocity so that the player actually jumps. And then here we have our handle gravity function. So we're going to call that handle gravity. And we'll pass in delta. So we'll pass in this delta right there. Perfect. And then we need to handle any horizontal movement in the air while we're jumping. We need to handle our jump to fall. That'll be our transition. And then we'll handle our animations. And like I said, you could technically, if you wanted to, just throw all of the code from these two functions just in the update function. It's just, for me, I like to separate it out so I know, like, okay, all the code that does this is down here. It's just a way of organizing it. Okay, so in this function, if the player velocity is greater than, or velocity y is greater than or equal to 0, then we want to change our state to states.jumpPeak. So I might have mentioned this earlier, but the jump peak state we're not going to do anything with right now. It's just a temporary state that if like you want to add some fresh animations or some other properties to your jump, which we'll be talking about jumps in the next video, you can use that state for that. So like if you don't end up needing it, you can actually just delete it. But I keep it in there just because sometimes I'll do some stuff in there. And last but not least, let's get those animations out of the way. So player.animator.play. This will be our jump animation. And then player.handle flip H without a capital L. Alrighty, so there's our jump state. Now let's hop on over to jump peak. Jump peak state. Create that. Extends player state. And then this one's very, very simple. So, okay, I'm getting sick and tired of writing those over and over. So, there we go. Nailed it. Easy. Crushed it. So we're going to, once again, put our name to be jump Peak. And then down here in the update, we're actually just going to send the player straight into the fall state. And then we'll add the function to handle our animations. But I mean, we're not going to use it right now, so we're just going to put it on pass. So yeah, so this is just like that transition state. Okay. Lastly, we'll go to fall state, and then we'll go back up and we'll just put the code in for lock state. Lock state is going to be, there's not going to be any code in there. It's just, I always put that state in there because if you do cut scenes or pause menu or other things like that, then you'll want that code in there. Okay, perfect. So we'll set the name to equal fall. Exit state, we'll leave that. Draw state, we'll do that. We'll come down to our update, and we'll call player dot horizontal movement. Call player dot handle landing. So that's when we land on the ground. And then we'll call handle animations. We'll add that in real quick. And some of you might be wondering that, or some of you might have noticed that we are actually missing a line of code in the update function. So if you caught onto that, good for you. If you haven't caught onto that, don't worry, we'll go talk about it right now. Right here, we need to call player dot handle brevity, passing in delta, because we are falling. And then right here, our locked state, we'll just add in the framework code. Perfect. There it is. So now that we have all those functions in there, we can actually come here and just get rid of all of that code. We don't need that handle animation code. We don't need that there. We just go down to the move and collide, or move and slide. So now this is the part where we run the project and see how many things are broken, because we forgot to do one or two little things, I'm sure. Yep, there we go. So node fall state expected 1 arguments. So current state update delta. So there's that. That's what we were running into earlier. Okay, perfect. Handle flip H is not defined. Okay, I guess we don't have that function yet. We're going to need that function. So this is going to be handle flip H, and all this function does is make sure the sprite is facing the correct way. And so it's the same exact thing we did before. Facing is less than 1 and returns a true or a false to flip that variable. It's just we're going to put it in the player function so we can access it. Oh, okay, we entered the state and now we're crashing. Now this is an ender state and idle state. Okay. Idle state, player dot change state, enter state, idle, ender state, idle, non-existent function, ender state in base node, idle state. Okay, so handle landing, change state, states.idle, fall state update, player physics process update delta, 75 current state. Oh, there it is. Enter state. How did I miss that beforehand? I was like, let's trace that. Okay, there we go. So now we say now we can see down here we changed from our null to our idle state. So now if I run, it crashes. Perfect. Horizontal movement. I say, I wonder how many silly little errors like that we've made. Okay, can we run? Yes. Okay, so we can run and we can idle. Can we jump? Okay, we have a puny, tiny, itty bitty little jump. So our full jump is not there. Idle to fall, fall to idle, idle to fall, fall to idle. So we're not going into the jump state. So let's go to idle. And that's going to be in our handle jump. So we go to player. Let's find handle jump, which should be right here. Okay, perfect. If key jump pressed and jumps is less than max jumps, velocity.y equals jump speed. Okay, so we're going to get rid of that right there. And now we can't even jump. Even better. I know why. I know exactly why. Do you know why? That's the question. We don't even go to the jump state. So it's like, it was jumping slightly beforehand because we were setting the velocity, which is why we got that little jump, but we weren't actually entering the jump state. So clearly, we need to check a few things here. Okay, that's correct. That's correct. Okay, so it looks like it was just this function that for some reason we just didn't send it to the jump state. Okay, so move left and right. Good. Okay, now we crash. Perfect. That's because I cannot spell. Lovely. Okay. Okay, I can't capitalize. Okay, so now we're still getting that little itty bitty jump. So let's try and figure out why. The player.handle gravity, that's there, perfect. Player velocity.y equals player.jump speed. Let's make sure all those variables are right. Jump speed, jump velocity, okay, that's all there. So if the player velocity.y is greater than or equal to 0, okay, so that's all working, but we're still just getting a little itty bitty jump. And I know our jump was at least like 2 blocks before that. Okay, so let's go back to the player state, see if there's something we're missing. Input states, current states, handle gravity. That is doubling our gravity right there because we're calling handle gravity in the jump state. There we go. Okay, so that's what was happening right there. So everything was working, but we were calling handle gravity twice, and that's why we were getting that little itty bitty jump. So now we should be able to run left and right, fall, jump. Perfect. There we go. Alrighty. And there we have it. We have a state machine for our player. And so this state machine will be very important into incorporating more advanced movements, which we'll start talking about in the next couple videos. The next video will be all about jumping and various jump mechanics. But yeah, if you have enjoyed this video, make sure to drop a like, drop a comment, subscribe, and I hope to see you in the next one.